Hello everyone. Now we are demonstrating one of our medical assistive device that is called Medicare that can help patient reminding to take their specific medication from time to time. And to prevent the taking the wrong medication, we have secured three drawers here that can be locked with a servo motor on the back of it actually. So the patient cannot pull open the wrong drawer actually and so if the patient mistakenly pulls the wrong drawer, it won't open because of the lock on the back of this device. So as we can see, there is three locks here that controlled by three servo motors that can lock the specific drawers according to our specification. And if the patient want to open any specific drawer, he will have to press this button here, then open drawer 1. So we can select this. Actually the drawer will be opened. So as we can see, there the drawer is empty, but we can put any types of medicine or any types of specific systems we want right here, and we can just simply close this drawer and the drawer will be closed automatically on the back of it. So we can see that the drawer is automatically closed now. So we are going to try to open the drawer once again so that we can show you the sensor behind this drawer that will help detect to determining if the drawer is open or closed. As we can see now, there is this particular sensor here that is called proximity sensor. This is operated by infrared motion sensor actually. So if the drawer is closed, we can see the sensor is blocked by this panel that will help determining the microcontroller that the drawer is closed, and he will close the door lock automatically. As for microcontroller, we have used ESP32 that has built-in Wi-Fi and Bluetooth, and we are going to perform some IoT operation over the internet in our smartphone app. And for that reason, we will have to connect this ESP32 with our home router or any specific network as we want. As we can see, the device is now currently in setup mode. That means the device is not currently connected with any network here. So we will have to modify this device to give the device the specific Wi-Fi credential and password to help this device connect to our specific network. For that reason, we are going to try our app here that's called ESP Rainmaker, and we will just simply add device here. As you can see, the smartphone opens up its camera that will search for any QR code present here, and the QR code is on our back of our device, that's right here. So we can just scan this QR code, and as this QR code scanning is successful, the app will now try to connect with the device here. Now the app is connected with our medication assistant device. As we can see here, this is our home Wi-Fi name, and it's the password right here. We can type the password. The password is previously saved because we have tried this device previously connected to Zero network, so it has saved the previous network name and password here. But we can choose any other Wi-Fi as we want, and we can type the Wi-Fi name and password right here. Then we can click on start, and as you can see, there is an option to save password. If we save this password, that device will remember this password, and every time the device restarts, it will automatically connect to this specific network. So as we press start, the app will send Wi-Fi credential to this device, and the device will remember this credential, and it will try to connect to the Wi-Fi network. Sometimes it shows some glitches, but don't worry, we can go to the device setup mode again, and we can scan the QR code again to perform this operation successfully. As we can see now, the device has confirmed the Wi-Fi connection, and it will trying to configure the node association and confirm the node association, then set up the device. That will do that the gadget for these devices will appear in our app home screen. As you can see, the notification is here that all the widgets we have imported into our app system, and we can see now that we have control over specific drawers and other checkups as well. So if we want to open the top drawer, we will simply have to click on drawer 1 state on. That will create a loud alarm here to notify the user to open the top drawer. Until the user open this particular drawer, the alarm will go on beeping. So as you can see, if we open the drawer, the alarm will go off automatically and the status will change from drawer closed to drawer opened. So we can put any sorts of medicine or any sorts of first aid kit here, and if we close this drawer, the sensor will detect automatically the drawer is closed after 5 seconds, and it will lock the device back there. And as the device is locked, the status will change from drawer open to drawer closed. In this particular manner, we can control all the other drawers in same way, and as you can see, all the other drawers have the same parameters right here. As for checkup purpose, we have a heart rate and oxygen level sensor right here that will measure the patient's BPM and oxygen level and also temperature. If we click on checkup button, you can see that it has 5 different parameters, and first one is for activating or deactivating the patient's monitoring system. We don't want to monitor the patient's vital information all the time. That will be needed in ICU, and that will have their dedicated equipment for their monitoring. But if you want to check the patient's vital data periodically, let's say we want to check after every 1 hour or every 2 hours, we can do that here as well. As you can see, the sensor is not activated right now because the body check is currently off. We can simply turn this on. That will go off the alarm here to tell the patient to place your finger right here. As you place your finger right here, it will take from 10 to 30 seconds to measure your beats per minute and also oxygen level. As you can see, as the patient successfully measured his BPM and oxygen level, the value in the display is automatically updated over internet into our mobile app as well. As you can see, the pulse value is matched with our display value here, and oxygen level is also matching with our display value. So there's 2 parameters right here, and there is also 2 other parameters to check the vital information, other information as well. That is, there is a last parameter called last check value, that is indicating that how much time before the patient have checked their vital information. That is also a crucial information for the doctors. If the doctor comes to visit the patient, he wants to know that when was the last time the patient did measure their vital informations. That will show in the screen right here. As we immediately measured our BPM and oxygen level, so it will not show much time, but after 1 minute it will change from 0 to 1. That means the last check value is measured in minutes, so the longer it passes, the larger the number will be. And there is also other parameters named interval period, that is set by the user to check the patient's vital information in which period. If you want to check the patient vital information in every 2 hours, we will have to simply set from 0 to 120. That means this is set in minutes, not hours. You have to remember this. So if the set is in 120, that means the device will go off alarm after every 120 minutes. That means after every 2 hours. And the patient will again have to place the finger right here to measure their blood pressure and oxygen level. If we don't want to bother the patient with automatic vital information checking, we can simply change the value from 120 to 0. That will disable the interval period, and you will have to manually check the patient's vital information by clicking from off to on right here. You can also check the patient's temperature right here. That will show the current temperature value and the other temperature value over the time here. So as you can see, it has measured some temperature in the specific period of time, and it is showing the temperature value in graph format. You can change from bar to line here, so you can specifically see when the temperature rise and when the temperature actually dropped. And the last feature would be the notice board. This is dedicated for our GSM module right here, that is used to send any SMS or Bluetooth to our mobile device to notify the user about any critical information. First, you will have to set your mobile number right here. So as you can edit here, and you can set your particular number you want to send SMS to. So I am setting my personal number right here. As we have typed the hello here and pressed OK, we have got the SMS from our Medicare device that is saying hello. Okay, so you will have to insert a SIM card right here, as you can see right here, that will use to send SMS and phone calls over your specific phone number that you are adjusting in your app, that is right here. You will have to remember that every time you send SMS from this device will cost some charge on this particular SIM card. So you will have to remember loading your SIM card with specific sufficient amount of money. And the last part is to send some debugging information from device to here that can be used for any particular purposes, such as if we press on drawer 1, that will send the alarm, and if the patient doesn't open the drawer within 30 seconds, that will send some update right here. Now we are testing this, actually opening the drawer, sending the drawer on, but not opening the drawer for at least 30 seconds. As you can see right here, the update is changed from type anything here to draw not open. That means we have commanded the drawer to be open, but the patient didn't actually open the drawer. That should indicate the patient didn't take his medicine. That can be used for automation purposes in this app. Known about all the basic controls in this particular app widgets, but that's not the full purpose or the not full feature of this device. Actually, we can utilize this in other parameters such as schedules and automations. We can set specific schedule for specific drawer to be open in specific time of the day. If we can type a specific name, let's say drawer. Let's say I am writing the morning medicine actually. So we are pressing OK, morning medicine. Then we have to type the time. But for your demonstration purpose, we are setting the alarm on 6:09 p.m. here. And you can set the repeat day as well. If we want to be reminded daily, we can also type the repeat value here. Then you will have to type the actions, that is the drawer 1, and the drawer 1 should be on right here. Okay, so we will have to tick the checkbox here, that is drawer 1 should be on, and we will have to press done here. Then you can save this schedule for later. And if the time goes to 6:10, then this schedule should kick in and the drawer 1 should create a loud alarm to be open, and the patient have to manually open this drawer to ensure that he has taken the medicine accordingly. Now we are closing to 6:10 here after 3, 2, 1. and the schedule has already told the top drawer to be opened, and you can see on notification as well. So if we pull the top drawer open, that is, the alarm would be put off and you can automatically close the drawer to successfully execute any scheduled medicine taking here. So you can do multiple schedules here. You can just simply click plus and you can say all the names. Let's say you have a specific medicine that should be taken on morning, on evening, and also at dinner. Let's say you have put the medicine on drawer 1. So what you should do, you can create a different schedule right here. You can say, let's say at night, then press OK. Then from the action you can also select drawer 1 and also select drawer 2. That means you will have to pull medicine out from both of these drawer actually. So you can just press done and you can set the specific time on 6:12 and then press save. So we have our new schedule ready here, and as the time goes to 6:12, both of the drawers will be open, and until we don't take medicine from both of these drawers, the alarm will should go on beeping and notify us to take the medicine from specific drawer. Now they're going to 6:12 and first it is saying open top drawer. Let's say we have opened the top drawer and the status says change from open top drawer to open mid drawer. That means even if we close the top drawer right here, the alarm will not go off. Okay, so we will have to also open the middle drawer, and that specific moment the alarm will go off and we can take the medicine out. We can close the drawers. That means we can tell the users to take medicine from both of the drawers at the same time. Now last comes the automation part here. Okay, we can imagine some scenarios when the patient is instructed to take off the medicine but the medicine was not actually taken out. What we should do, we can call any authorities or we can send SMS to a particular number to tell that the medicine was not actually taken and the patient should be checked up immediately that if something has gone wrong. So we can just simply add automation right here. We have to type the system. Let's say we are saying that patient unresponsive. We can just click OK, and we will have to choose a specific parameters that will trigger this automation system. We can click on checkup and we can click on notice, then here on update, that is draw not open, that is equals, then we can press confirm. That means when the ESP32 or the Medicare assistive device send an update about drawer not open, this automation action will be triggered. So we can simply click on notice, then SMS, and we can just type any SMS right here. Let's say we can write that patient did not open the drawer. Okay, so we can just press OK, then we can click save. So we have successfully created an automation scenario. Now we will have to see that if we send a command to open any drawer but a drawer is not open within 30 seconds, let's see what it does do. As you can see, after 30 seconds of not opening the drawer, the automation system has kicked in successfully, and also we have received an SMS about that patient did not open the drawer. That's how we can set our own automation criteria and we can execute our needs accordingly. Let's think about other automation systems as well. That is, let's say the blood pressure or the BPM goes below 60. What we should do? We can simply add another automation, that is BPM to low. Then you can press OK. Then select event. Okay, we can click on checkup. Then we can click on pulse value, and the pulse below we are setting as less than 50. Okay, so we can click on confirm. So if the pulse value is less than 50, what it should do? It can send any SMS. So we can just simply click on SMS and edit here. That is that pulse value to low. Then click OK. We can also open any specific drawer that is containing any emergency medicine for that low pulse scenario. So we can simply click on drawer 1 and set the status in on. Okay, so now we can save right here. Now we are going to test this automation system. That is how we are going to simply click on checkup, then click on body check on. Then we have to place this finger right here. So think of a situation where our BPM goes below 50, but it's not currently going below 50. We are trying to recreate the scenario by quickly placing our finger and removing this from the sensor. As you can see, the BPM is now currently in 32. Okay, so that is really low value. So that is also triggering the open drop drawer and also sent an SMS that is saying that pulse value is too low. So we can just simply open the top drawer, take the emergency medicine out, then we can tell the patient to consume that medicine. That is how we can elaborate any sorts of automation system according to users' need. So the main feature of this device is that nothing sorts of automation is currently set in the code of this device, and it is completely user customizable, user modifiable, and user can control every aspect of feature on this device. That's all from this Medicare device. Thank you for watching this video. Hope you can understand these features and regard us as well. Sure.